Hey guys, welcome back. I decided to do a different style of video today, and I was debating. I wanted to kind of retry my old GCSE papers, and at first I obviously picked the maths paper, but then I figured that might be a bit boring because I'm currently a maths teacher and tutor, so it probably won't be that hard for me. I'm not trying to flex. However, if you want to see that, leave a comment and I'll maybe do it if there's enough demand for it. So I decided to do something that I haven't done in a while, which is physics. So for those of you that aren't aware, my degrees are in physics. However, I haven't taught GCSE physics specifically in a while, and A-level physics I haven't had students for like a year. So this past year I didn't have any A-level physics students, so I'm a bit rusty. Not just that, but the spec has changed since I did it back in 2013. So this should be kind of interesting. I did triple science, so I picked the triple science paper 1 for physics. There are 3 papers in total, so if you want to see the other papers or if you want to see maths, let me know in the comments down below and I'll see if I can do it if there's enough demand for it. I just wanted to see if this would be interesting for you guys. So the specs changed. I haven't seen all of this in a while. I have a calculator. I didn't get the equation sheet. This is basically all I can see at the moment. But again, I do have my trusty calculator over here that we'll use if we need to. But without further ado, let's get into it. It's 60 minutes, this is an hour, so let's see if we can get it done before then. So let's go down to the first question. So Sankey diagrams, okay, so that's normal. So energy transfers in a traditional coal-burning power station and a combined heat and power station, CHP. Okay, so Sankey diagrams, they show you how much waste energy and kind of useful energy that something produces in a proportion. So what effect does the waste energy from a power station have on the surroundings? So just so you're aware, I do have a black pen, but I'm also going to be typing quite a bit of this because I'm incredibly lazy. And I kind of low-key want to type some of this. But for this, what does it have? It just heats up the surroundings, right? So this we have a Sankey diagram which shows the energy transfer in a traditional coal-burning power station and a combined heat and power station. Okay. And cool. So Sankey diagrams, they show you how much energy is inputted and then the useful and then the waste energy down below. So you can see the proportions. What effect does the waste energy from a power station have on the surroundings? Well, one of them could be heating up, although that's not really... I mean, it is technically a heat up surroundings. It is technically a waste energy, even though you want the heat from a power station, but some of that heat is radiated to the surroundings. You could probably also say sound as well. So I'm not going to count this in my marks because obviously you're not allowed to put more than one answer, but just as a reminder to see which one it is. So I'm going to do the marks at the end, of course. So I'll make sure I won't mark that as correct if that's what I see. Again, I'm using a black pen, but I also want to type some of this because I'm lazy. Perfect. So calculate the efficiency of the CHP station. Okay. Use the correct equation. Again, I don't have the formula sheet. That's fine. So all you need to do is count up the squares for the input, and then you're going to count the squares that are useful. However, a small trick is you can just take away the ones that are missing. So how many are in total? So we have 1, 2, 3, 4, 5. That would be 10, 15, 20. So there's 20 inputs. That's going to be at the bottom of our fraction. And how many are out? So it's 4 few. Oh no, it's not. It's 1, 2. Yeah, it's 4. So 4 of them is waste energy. So 20 minus 4 is 16. So 16 out of 20. Which in other words is 8 out of 10. So that would be 80% efficiency. Not bad. Cool. Next. Why is a CHP station more efficient than a traditional? Simply put, just if you didn't know what a CHP station was, and to be honest, I don't quite remember, it tells you here. Energy used to heat local homes and offices. So some of the waste heat energy, so the waste heat energy is made useful by heating up local homes and offices. That's all you have to say, right? Because that's why it's more efficient. Because you're changing waste energy into useful energy. This other waste energy is probably stuff like sound. Yeah, so 2 marks, that should be fine, hopefully. CHP station is usually used to meet demand for electricity within the local area. The electricity is not transmitted and distributed through the national grid. What is the national grid? It is a system of cables, transformers, and power stations. It's all of them. Using the electricity locally and not transmitting it increases the overall efficiency of the CHP station by 7%. Explain why. Simply put, it is because energy is not lost through heating of wires over long distances. So if you imagine that we produce the energy in, let's say, Scotland, and then we pipe it all the way down into London, for instance, over that long distance, it's going to heat up the wires inside, which is waste energy. I don't know why I'm explaining this. I don't know if this is useful. I should just be answering the question to see how quick I can do it. So why do showers get misty? Okay, so it's 3 marks, so I need to put 3 bullet points. So let's get started. So the first one is water vapor comes into contact with mirror surface. Surface of mirror is cooler than surroundings. Water vapor condenses onto mirror. And then I'm just going to say causing misty. Causing misty. Sure. So these 3 points should give me everything I need. The homeowner installs electric heater meter when a person has a shower. It does not become misty but stays clear. Why? Because now there is no temperature difference between the mirror and the air. So no condensation. So that's actually a good tip for life. If your windows or mirrors are getting misty, generally speaking, that's just because there's a difference in temperature that causes condensation, which can cause mold. So for when you guys are homeowners. Okay, light waves transfer energy. Complete the following sentence. Oscillations producing a light wave are something to the direction of energy transfer. Because it's a transverse wave, they are perpendicular. The apparatus in the diagram shows that light waves transfer energy. Okay, cool. So there's a desk lamp, solar panel. Okay, cool. So when the light from the lamp hits the solar panel, it produces electricity, which causes the fan to move. So describe how switching the lamp on and off. Okay, so describe how that specifically. Okay, so when the light is on, the solar panel produces electricity, and the fan switches on. When the light is off, the fan stops spinning as no electricity is produced. Right, it just says describe, so you don't need to say like why or anything like that. Okay. Okay, a student holds a wristwatch in front of a plane mirror. The student can see an image of the wristwatch in the mirror. Yeah, okay, that's fair enough. The diagram shows the position of the wristwatch and the mirror. Draw a ray diagram. Okay, showing how the image of the wristwatch is formed. Mark the position of the image. Okay. This is one of those things that was kind of taken out, or it might be only in triple science at the end. Obviously, I can draw ray diagrams for refraction, reflection, and all of that stuff. Total internal reflection, things like that. But this is a virtual image. Yeah, so what is a virtual image? Simply put, it's an image that can't be formed on a surface. So image cannot be formed on a screen. That's a bit of a weird definition, but essentially it appears as though the image is like behind the light source, right? In this case, which is the mirror, right? Okay, so 4 marks, Jesus Christ. Obviously, what I'm tempted to do is just draw like a straight line going here and then going straight through, because when you, and we'll just call it virtual, because if you think about it, when I look in a mirror, I have a mirror to the right of me, by the way. When I look into a mirror, it's just like a straight line. That can't be the answer. That can't be. So what I'm going to do instead as well, or in addition to, see, the thing is, just right in front of a plane, can see. So realistically, on this diagram, there should be like an eye somewhere, so something that looks like this, right? Which tells you where the student's looking from, because then you could also say it's like this. So the reason why they can see it inside the plane is because there's a bouncing ray, so to speak, from there. Crap, yeah. I'm just going to leave it as that. I think that might be the first marks I've definitely lost. Okay. In this question, you'll be assessed on using good English, organising information clearly, and using specialist terms where appropriate. The diagram shows the structure of a vacuum flask. Okay. So it's designed as a insulator. Reduce the rate of energy transfer by the heating process. Describe how the design of a vacuum flask keeps the liquid inside hot. 6 marks. Okay, so 6 marks, 6 bullet points. This one's actually a pretty good one, because if you have a look, there's 5 things we can talk about. Well, about 4. So how it keeps the liquid inside hot. So what I'm going to do first is literally just list the different special things. So the silvered surfaces, what's good with that? Well, think about what silver is. It's reflective, right? So silver surface reflects infrared radiation back towards the liquid. So prevents heat loss by radiation. What next? We have a plastic cap. So plastic cap prevents water vapor escaping, which prevents heat loss by evaporation. We have a vacuum just having is a very good insulator. So the vacuum space acts as a strong insulator. And why is that? Because there are no particles to carry heat away from the hot liquid. So this is by conduction. Could it be convection? No, it's not convection. Okay, double-walled glass container. Again, this is actually how your windows are structured as well. So let's think about what else we can write. I may have gotten 4 or 5 marks already because I've said what the heat loss is from, like conduction, radiation, evaporation, so maybe that's 6 marks. But the double-walled glass container, we have to talk about that. So again, for tips with this, even though most of you probably aren't doing GCSEs anymore, is look at the diagram and explain everything. So the double-walled glass container provides an additional layer of insulation, damn it, which prevents heat loss by conduction. Instead, you have that the inner surface has to radiate heat away. By the way, yeah, so I think with this is an American spelling, that's why. Unless that isn't how you spell evaporation. That's embarrassing if not. So I think that's all okay. So how it keeps the liquid inside hot. So yeah, all of these reduce heat loss, right? Keeping liquid hot. Again, even write obvious things, it could be a mark. Arctic foxes live in a very cold environment. Arctic foxes have small ears. How does the size of the ears help keep the fox warm? Okay, so this is all to do with surface area to volume ratios. So ears have a large surface area to volume ratio, which increases heat loss due to radiation. Small ears lower the surface area to volume ratio, reducing rate of heat loss via radiation. Simple. That's why desert animals have very long floppy ears and things like that. So African elephants, for example, whereas Arctic creatures tend to have less surface area compared to their volume. So even like polar bears, for example, they're very big, but they don't have kind of extraneous things. They don't have large floppy ears and things like that. So generally speaking, if something's large and thin, it's good at radiating heat away. That's why things like desert mice have very, very big ears too. Yeah, that's good. An electric immersion heater is used to heat the water in a domestic hot water tank. When the immersion heater is switched on, the water at the bottom gets hot. Yeah, makes sense. Energy is transferred by the process of convection from the hot water at the bottom of the tank to the cooler water at the top. Explain how. 4 marks. We need 4 points. Okay, so water at bottom of tank gets hot because of the heater. As water heats up, it expands. This reduces its density, causing hot water to rise. This causes cooler water to sink towards the heater at the bottom of the tank. Yeah, that's pretty much it. So yeah, cold water comes in, it heats up, so it goes up to the top, which kind of forces cold water to go down because it separates into layers. Remember, when you have liquids, they always separate into different densities. So hot stuff will be at the top, cold water will be at the bottom. That should be fine. I'm so paranoid about losing like 1 or 2 marks. Because even, that's the thing is, even though I know how it works scientifically, that's not enough to get marks in GCSE science. You have to actually explain it in the words that they want, which is kind of an annoying part. Complete the following sentence. The main way the energy is transferred through the copper wall of the tank is by the process of conduction. I have to think for a second. The immersion heater has a thermostat to control the water temperature. When the water temperature reaches 58 degrees, that's really hot, okay. It switches the heater off, and then it turns back on at 50 degrees. Okay. Graph A shows how it... Oh, that's fine. Okay, this is easy. So the temperature of the water falls at the fastest rate just after the heater switches off. So just in case you're aware, temperature difference is the main cause of temperature change. So the bigger the difference in two temperatures, the faster it will kind of reach that equilibrium. It'll begin to change temperature, which is why when you have things like nuclear fusion devices, they have plasma that's at tens of millions of degrees in temperature. And people are worried about that kind of exploding. But the truth is it wouldn't. It would cool down so incredibly quickly that it would become very safe to handle almost immediately. Because the temperature difference is so high, right? Millions of degrees versus room temperature at like 27 degrees or whatever. Okay, to explain why. Because the larger the temperature gradient, the faster the rate of change of temperature. So at the beginning, sorry, I should actually say just after the heater switches off, there is the largest difference in temperatures. This is also why like hot food cools down quickly and it stays warm for a really long time. And same thing with like drinking tea or whatever. To heat the water in the tank from 50 to 58 degrees transfers 4,000 kilojoules of energy to the water. Calculate the mass of the water in the tank. I don't even need this because I know this equation because it comes up in A level. It's E is equal to mc. I believe you guys use delta T, but in A level physics we use delta theta, but it's the same thing. So we want the mass, right? So if we rearrange that, I'm just going to divide everything over to the other side. We have E. God, my handwriting's so bad after having not... Just so you guys are aware, this is like the last week of the summer holidays and I haven't done like anything educational. So it's not good. So 4,032 kilojoules. Okay. That's in joules per kilogram, so I need to change that into joules. Okay, so I'm just going to leave it in standard form because I'm being slightly lazy. I'm pretty sure that's what you have to do. And C delta theta, so that's 4,200. The change in temperature from 50 to 58 is, of course, 8. That looks like a decimal point. It's actually a time sign. Again, I'm being a bit lazy. So far I've been recording for 16 minutes, so I'm hoping that it's not going to take much more than this, because technically I only have 60 minutes. 3, and then we have 4,200 multiplied by 8. 120 kilograms. That's probably about right, to be honest. Okay, perfect. An insulating jacket is fitted to the hot water tank, and it shows how it changes with time. Okay, cool. An insulating jacket costs only £12. By comparing graph A and B, explain why it saves money. I don't even need to compare it, but if you look here, you have to turn on the heater a lot more frequently. So, you know what? In a 4-hour period, without an insulating jacket, the heater must be turned on 1-2 times, right? With an insulating jacket, this only needs to happen once. This halves the amount of energy spent on heating up water for only £12. Less energy usage saves money. I don't know. I know I wrote an extra point, but that's because I'm so paranoid about losing a mark that I'm writing extra stuff. See how long ago this is. Oh my god. In the UK, over 70% of the electricity is generated in power stations that burn fossil fuels. This is nowhere near accurate anymore. Yeah, this has reduced a ton since I did GCSEs. This is back in 2013. Anyways, explain one effect that has on the environment. Releases large amounts of CO2, which contributes to global warming / climate change. The reason why I write either or, because I think climate change isn't really used anymore. They normally use global warming instead. So, but back then, like, both were acceptable. So give one way the effect on the environment described in part A could be reduced. Oh, crap. Dang it, I should have said something else. Okay. How could it be reduced? It can't be as simple as planting more trees. Using carbon capture devices? Could I say... Alright, I'm going to put this in brackets again. I think I might be overcomplicating it. I can't remember if carbon capture devices were on the spec back then. So plant more trees should have been what I wrote. It's fine. If I lose the mark, it's fine. Electricity can also be generated in a pumped storage hydroelectric power station. An advantage is the short startup time they have. What is the importance of the short startup time? You can respond to changes in demand for electricity faster. Give one other advantage of a hydroelectric power station. Well, doesn't release CO2. I've got a feeling I've lost marks on this section. Hardcore. Oh my god. Okay. 20 minutes. Alright, so read the extract below from a newspaper article. In the future, it may not be possible to have constant electricity. Families have to get used to using power when it's available. In the UK, the proportion of electricity generated using wind turbines is due to increase a lot. Some opponents of wind turbines think this will increase. Just one reason. Oh, okay, that's easy. This is because wind speeds fluctuate. Because wind speeds fluctuate. God. And depend on the weather. Cool. Between 2002 and 2008, the amount of electricity... Oh, LEDs / more efficient light bulbs. Yeah. Cool. Damn, back when filament bulbs are a big thing. Jesus Christ. Alright. Electromagnetic waves form a continuous spectrum with a range of wavelengths. What is the approximate range of wavelengths? Okay, technically speaking, it can be any, by the way. So, the smallest one... Okay, so I'm going to eliminate this by step. First of all, 10 to the 15 is enormously huge. Just so you're aware, that's like... It's 10,000 times bigger than the distance from the Earth to the Sun. So the Earth to the Sun is 10 to the power of 11. So it's definitely not that. So, definitely not this one. 10 to the minus 6 to 10 to the 6. Well, 10 to the minus 6 it can't be, because you know that there are ones that are smaller than 10 to the minus 6. Right, like gamma radiation. So it must be the first one. Infrared. Give an example of infrared radiations. Infrared waves being used for communication. I know this. Why can't I think? It can't be thermal imaging. Give one example of infrared waves being used for radiation communication. Why can I not think? Isn't it remote controls? Crap. Dang it, I can't think. Okay. A mobile phone network uses microwaves to transmit signals to the air. The microwaves have a frequency of blah blah blah, travel speed blah blah blah, calculate wavelength. That's fine. C is just equal to f lambda. So then we're trying to work out the wavelength. So lambda is equal to c over f equals 3 times 10 to the power of 8 over 1.8 times 10 to the power of 9. which gives me the final answer, which I'm going to work out now. It's been so long since I've done this, and I'm sure that a lot of this is actually not changed, but like has been like on and off the spec. Oh, I'm pressing the wrong bloody key. That's why. 1.8 times 10 to the power of 9. Ooh, that was close. Cool. 1/6. Really? Yeah, that makes sense, Margaret. Okay. So two significant figures, so 0.17 meters. 3 marks for that. All right, fine. Happy with that. Some scientists suggest that there is a possible link between using a mobile phone and male fertility. The results show. So, is this real? Is this real? Damn. Oh, okay. The result shows a negative correlation. The more hours the mobile phone is used each day, the lower the sperm count. However, the results not necessarily mean using a mobile phone. Suggest one reason why. It's because correlation does not imply causation. Other factors have not been taken into account. Things like age, for argument's sake, could be taken into account. These people could be drinking, they could be smoking, or all sorts of other stuff that can affect their sperm count. How many people were there? Oh, okay, never mind. It's a great study. Ooh, Big Bang Theory. Okay, I should be able to do this. Observation of the spectrum from distant galaxies. Blah, blah, blah. Many scientists think that the Big Bang Theory describes the origin of the universe. See, it's one of those things. It's like you have to remember like a specific sentence. That might not give me the right mark, which is fine. Discovery of cosmic microwave background radiation because it provided more evidence. It didn't prove the universe will continue to expand forever. No, that is to do with the matter density of the universe. Many stars are part of a binary star system. Binary star systems have 2 stars. See what I mean? And this is, I think now most of this is in triple science. Maybe? The visual spectrum includes dark lines, the lines at specific wavelengths. This, by the way, comes up in A-level physics in the astrophysics department, which is predominantly AQA. You get a choice of modules. Okay. The diagram shows the position of 2 dark lines in the spectrum from the sun. I should know this. It also shows the same spectrum from 2 stars A and B. So we're looking at what's the name of the effect. Name of the effect. It is. I mean, it's an absorption spectrum. No. Actually. Absorption spectrum is when it passes through. It's an emission spectrum. I misread the question. I thought it was like it's light going through this star and then blah blah. 2 dark lines, yeah. Oh no, that is an absorption spectrum. If it's 2 dark lines, it's an absorption spectrum. Yeah. So basically, what this is, an emission spectrum shows you just the wavelengths of light that have been emitted. So generally speaking, from like a star or something like that, or a planet's atmosphere. An absorption spectrum shows you what elements are present in the atmosphere. Okay. So for example, this line over here, more than likely is something like hydrogen, and then maybe helium or something like that, which makes sense because the sun is made up of hydrogen and helium predominantly. So these atoms will absorb specific wavelengths. So if they're dark lines, they're absorption spectrums. If they're bright lines, they're emission spectrums because they're showing you what wavelengths a certain element or something will emit. Which is why it's a good thing I reread that. So it should be, it says an effect. I'm going to say absorption spectrum. Scientists have concluded that the 2 stars in the binary star system orbit around a fixed point. A comparison of the spectra provides evidence to support this. You know what's really bad is I took so many astrophysics modules at university. Okay. Scientists have concluded that the 2 stars in a binary star system orbit around a fixed point between the 2 stars. A comparison of the spectra from the 2 stars in a binary star system provides evidence to support this. Oh, okay. No. I know what this is. This is to do with, what the hell is it called? The Doppler effect. This is going to be so bad if this is wrong. Because it's going to be so stupid. It's so overcomplicated. Essentially, star A and star B should be made up of the same stuff, right? Which means they should have the same spectras, okay? So they should have this diagram here. But instead, if you notice, star A is shifted to the right, star B is shifted to the left. This is because star A is moving away from us, whereas star B is moving towards us. So star A is moving away from us, hence the spectra is shifted to longer wavelengths. Star B is moving towards us, hence the spectra is shifted to shorter wavelengths. I am 99% sure most of you won't know this from GCSE, to be honest. But it's the reason why if you hear like an ambulance or a police car driving really quickly towards you, the siren sounds really high pitched and frequent, and then as it goes past you, it sounds deeper and it's further, like the sounds are further apart. This is the Doppler effect. Same thing happens with light coming from distant places. So for one star to be moving away and the other to be moving towards us, they must orbit a common center of mass. Okay. If that's wrong, I'm going to cry. Alright, is that the end? That is the end. Okay, let me get the mark scheme up and I'll split the screen in two and then we will mark and see how many marks I got. What is it out of? Damn, that's a long question. 60. Okay, well, let's see what we get. 60 marks in 60 minutes. Wow, bloody hell. Okay. Let's quickly discuss all the different ways that I'm going to help you in your GCSE or A-level maths careers. First of all, I wanted to talk to you about the YouTube members. This is a really cost-effective way of getting tutoring. So I'm going to do weekly live streams for GCSE and A-level maths, and that all comes for £18 a month, and you get at minimum an hour of tutoring per week in these live streams. At the moment, they're quite small, so you basically get tuition for about £4.50 an hour, which is really, really cheap. The second thing is the Patreon. For those of you doing A-level maths, I have already completed AS Stats on my Patreon. It is a full course with worksheets, mark schemes, videos. I answer all the questions. We're going to do exam papers and everything that needs doing. We're halfway through mechanics as of yet. And lastly, there's tuition. I still have places in my group classes for A-level maths and GCSE maths. For GCSE, it's £30 an hour, and for A-level, it's £40 per hour. So if you want to let me know if you're interested, just email me or join the Discord where I'm very, very active all the time. Anyways, back to the video. Okay, I know it's a bit squished, but this is how we're going to do it. So if we go down to question 1, the very first question, we were unsure of what our kind of answer would be. So let's have a look-see. Bloody hell. Warms it. Heats up is fine. I'm giving myself the mark for that. Efficiency, 80%. Look at that. I've still got it. Alright. Oh man, I thought I didn't read it. Okay. So some of the energy that would be wasted is useful. So, which is what I wrote. Cool. If you guys think I'm being too generous, I'm not. System of cables and transformers. Oh, of course the power stations don't count. Of course they don't. Of course the power stations don't count. Of course they're not part of the bloody national grid. Alright. Less energy lost, power lost in shorter cables. Yeah, that's what I did. So in that I got 6 out of 7. Right. So I said water vapor comes into contact with the mirror surface. Mirror is cooler, so that gives me 1 mark. Causes condensation. So it doesn't. It looks like I don't get the mark for saying that it comes into contact. Yeah. All right. I'm not gonna take it personally. It's fine. It's fine. It's fine. It's fine. All right. Why does the mirror stay clear once you get a heated mirror? So I said now there's no air in. Okay, cool. So mirror surface is warm, rate of condensation is reduced. I get 1 mark, I guess. Wow. Okay. Man, it's got me a bit vexed. Alright, that's 3 out of 5. Jesus Christ. See, I told you, I'm going to lose dumb marks on stuff like this. So again, like, what I'm saying is correct, but that doesn't matter in science. Okay, the next was the question about everything perpendicular. Of course I got that right. Light off, no rotation. Yeah, fast rotation. Yeah, cool. Okay, this is going to be interesting. I don't actually know how I'm going to mark this because the mark scheme... Okay, so 1 ray drawn from the wrist watch and reflected by the mirror. So I've done that. 2 rays drawn from the wristwatch and both reflected. 1 ray... Okay, so 1 ray traced behind. That's what I did here. 1 ray with the incident and reflected, I did that. Image in the correct position? I mean... Right? The only one I'm... Is that 4 marks? 1 ray drawn from this... See, this is 1 ray and then 2 rays. I've done 2 rays. I'm going to give myself 4 to make myself feel better. It was a virtual image. Cannot be formed on a screen. Did I write that? I did. Cool. I can't believe I remembered that. So is that 8 marks? Yeah. Okay. Again, if you think I'm being a bit too generous, then let me know. Alright, then it was to do with this one is 6 marks. So I think you do get like quality of written communication. Yeah, this is kind of annoying. But, wow. Oh my lord. Okie dokie. So, plastic cap prevents convection guns. Okay, I didn't say that. Prevents molecules evaporating, though. I did write that. Alright, glass container. Glass is a poor conductor. I'm pretty sure I said that. No, I didn't. Shoot. I did say it stops it by conduction, though. The vacuum. Both conduction and convection provide medium. Yeah. So it prevents convection. That's what I said. No, I didn't. I said conduction because I'm an idiot. Alright. But I did say that there's no... But oh, it does say by conduction and convection. Okay, there we are. So I was partially correct. And silvered surfaces reflect infrared radiation. Okay, so that is 4. So now I need to... like, work out if I got anything else. I don't think those last 2 would have gotten me stuff, to be honest. If I'm being honest, I think that's a 4. It's a no from me. Alright, cool. Part B, small surface area reduces that. Cool. Small surface area to 1. Yeah, cool. So it's 2, so I got 6 out of 8 because I dropped 2 marks before. Okay. That's fine. Immersion heater. Let's go over to what my answer was. Oh, come on. Really? I've already got 2 marks. Gain energy move on. Fine. 2 marks it is. That's... Again, what I'm saying is technically accurate, but I guess it's not technical enough, if that makes sense. And it is through conduction, so that is perfectamundo. Yeah, so again... I need to approach this looking at it from like a scientific perspective. Like, why exactly does the water expand when it's heated? Things like that. That's what I didn't do, which is not good. Okay, fancy part I. Bigger temperature difference. So the rate of... Okay, I did say that. 120. Good, got that. So far I've only dropped 2 marks, right? Yes. Why is it better? Yeah, that's fine. So that should be 11 marks. Cool. So produces carbon dioxide or nitrogen oxides, contributes to global warming. There we are. So you know, so they don't say climate change. Interesting. They don't even accept climate change. All right. Collecting carbon dioxide is sufficient. Carbon capture and storage. Or plant more trees. Okay, I'm gonna give myself the mark for that because I did have that. To meet surges in demand, changes in demand faster. Doesn't release CO2. Except does not produces CO. Does not produces. Does not produces. Okay, does not produce CO2 is what I meant. Okay, so some other nonsense about this. Do not generate at a constant rate. Wind speed fluctuates. There we go. LEDs. LEDs. Where's LEDs? Energy efficient. More efficient light bulbs I also did right. Okay, cool. I think this was the last question, right? Yeah. 10 to minus 15. Yep, cool. So that's the one I did. Perfect. Remote controls. Remote controls. Okay. 0.17. Maybe other factors involved. Or you can name a factor. Interesting. It's only 1 mark, yeah. What, 6 in that? No, there's another question. Alright. Oh, yeah. I forgot about this. That was quick. Origin of the universe. Provides more evidence. I'm not even going to read the mark scheme yet. Redshift. Yeah, that makes sense. I knew it wasn't an effect as well. Crap. Alright. I mentioned the Doppler effect in the next bloody question too. Alright. Okay, but I got this. This is pretty much entirely correct. So, star A is moving away from us, star B is moving towards us. Both of those are correct. Oh no, I got the full marks, yeah. Because I wrote about the longer wavelengths and everything. Okay. So did I only lose 1 mark in that? Okay. 5. Alright, let's quickly add up our marks. We have 5. Add 6 is 11. Add 7 is 18. That is 29. That is 35. It's 43. 46. 52. Oh, 52 out of 60. Yeah, so a bunch of kind of annoying little bits, which again is why if I was teaching this old spec, because in the new spec they're a lot more lenient in terms of your wording, because it's really dumb to make people like memorize exact phrasing, right? That it doesn't make sense. That isn't actually a way on how to gauge someone's understanding. So I'm gonna say 87%, which yeah, I still got my A star in physics, assuming I get the same in the rest of them. But yeah, that's going to call it for today. But again, if you want me to do the maths paper and maybe even physics P2 on P3 for my triple science, then let me know in the comments, see how kind of useful or funny this was to watch. I'm surprised I got this low, to be honest. But I was kind of harsh on myself at times too, but I was also a bit lenient, so who knows? Who knows what I would have actually got. But without further ado, I'll let you guys get on with your day. I hope you have a wonderful one, and I'll see you in the next one.